Hi, everyone. Thanks for joining us today. I think we'll go ahead and get started now. As folks continue to log in, we'll catch them up. I'm going to kick us off with a couple of housekeeping items, but to make sure everybody's in the right place, you are joining Teren and Pipeline Logic for unleashing the power of weather and external force data to identify environmental threats. This webinar is the first of a series of Teren's Environmental Twin webinar series. So there will be information at the end about additional webinars you can attend to learn about different approaches to managing environmental, weather, and other threats. So first up, some housekeeping items. All attendees are muted. If you'd like to ask questions, please use the bar at the bottom right corner of your screen. You can chat with the presenters or you could submit questions through that. All of the questions will be answered at the end of the call today. So please hold tight. We're not ignoring your questions. We'll get to them at the end. And if we run out of time, we'll follow up with you individually. This will be recorded so you can share it with folks after today or watch it again if you just really love it. I'm going to take a couple minutes and introduce each of our speakers to you. We want to tell you about our speakers and let you know that they're experts in environmental threats and integrity management. And then I'm going to hand it off to the team to get into today's content. So first up, we have Brian Ellis, president of Pipeline Logic. Brian is our guest today, and he has 24 years of experience in the pipeline integrity. He got his degree in metallurgical and materials engineering from Colorado School of Mines. He's known for industry-leading risk assessment solutions and has helped spearhead the federal liquids and gas integrity management rules. He's worked on all aspects of pipeline integrity programs from executive management to leading engineering and pipeline companies worldwide. He's done field assessments, anomaly mitigation, retrofitting facilities, TVC and GIS data integration for mega rule compliance. And he's worked with operators such as PG&E, CapturePoint, Shell, Total, Excel, Enbridge, TC Energy, and the list goes on and on. We are so grateful to have Brian here with us today. He's currently focusing on geohazard management, which you're going to hear a little bit about today, materials verification for the mega rule, emerging integrity threat mitigation programs, and also leads industry and university collaboration for inclusion and diversity, a topic he holds and we at Teren hold near and dear to our hearts. You'll also be hearing from Austin Savage. Austin is our Director of Operations here at Teren, and he is an experienced geospatial professional focused on aerial sensor platform workflows, flight planning, operations, and customer success. Austin has extensive collection and production experience, and he's helped set a new standard for processing geospatial data unbelievably fast. He's going to talk to you a lot today about flight planning and how to prioritize areas that need additional LiDAR investment. His background includes project management, imagery and LiDAR production, and airborne GPS trajectories. And then the first person you're going to hear from today is Jake Opdahl. Jake is our Director of Sales at Teren. He brings over 20 years of experience in geospatial technologies and business development. He's also focused on enterprise software sales, GIS implementations, handheld technologies in the field technologies, and marketing. Jake manages the strategy and execution of bringing Teren products to market and selling them to the industry. He's focused on transforming complex data into actionable, decision-ready insights to help pipeline operators and other customers really identify how best to solve the problems they're facing. So with that, I'm going to hand things off to Jake, and we'll get started with our content.
Great. Thank you, Stacy. And thank you, all of the attendees here, for taking some time out to join us here today. Really excited to share this information and to share this stage with Austin and Brian. So just to kick things off, a little bit about what we're going to cover here today. You've heard the term digital twin. We all have. We're focusing here on an environmental twin, right? Whereas a digital twin is typically a representation of a building or some type of infrastructure. here at Teren, we focus a lot on the environmental factors, in particular threats and risks to those assets. So most of you here today are within the pipeline industry. That's where we do a lot of our work. We do have folks who are joining us from other industries. We'll be largely focusing on pipeline examples and how we're leveraging this technology and data within the pipeline industry. But this certainly applies for anyone who's managing a physical asset on the surface of the earth that might be prone to certain types of environmental risk. Geohazards, landslides, things of that nature, river scour. We're going to touch on a few of these things here today. And a lot of what we'll talk about here today is focused on the Teren Essentials program, which, as we'll dive in here, you'll see there's a number of different threat and susceptibility layers that we work with and we analyze in conjunction and correlation with your physical assets. So it's all about this external force threat, be it from physical earth movement, be it from weather, things of that nature. And where does that apply to particular industry needs? And we'll get into a bit more of that detail here in a bit as well. We'll cover a demonstration. We'll look at a few of the different layers that we provide and that we use in our analysis. And then we're going to cover a couple of the primary use cases that we see, in particular within the pipeline industry, for leveraging this data, right? Be it from a risk model input perspective or prioritization of where to apply additional resources to further identify, monitor, and report on these particular threats to these assets. So with that, we'll move here to a few of the other kind of key points or learning objectives that hopefully you come away with here today, and hopefully we're able to share this in a effective manner. So we're going to talk a lot about these different data layers that associate with risk and threat and things of that nature. And throughout this presentation, we'll touch on some of the importance of really the statistical validation of these models. We want to make sure that this data is defensible, it's actionable, but should you be in an audit, should you need to defend this, what is the statistical validation behind these models, behind these data sources? We'll also hit on the climate-informed perspective quite a bit here today as well. And really what we're looking at there is how can we provide some more dynamic and near real-time information coupled with some of the other data sources to really help the folks we work with understand potential risk to their assets. And a lot of that is based on precipitation, temperature, things of that nature. As I mentioned, we're going to talk a little bit about some of these use cases. So what are some of those critical steps, right, to integrate this data? We have all of this robust, high fidelity information. How do you integrate it into a risk model? How do you leverage this for your day-to-day tasks, for your role and responsibility at your particular company? Part of that as well is we'll talk about, Austin will talk a little bit later here about how we can leverage this data to help you further prioritize additional geospatial inspection, be it finding those discrete landslides along your right-of-way, or finding areas where there may be depth of cover issues due to agriculture or other factors like that. So hopefully we hit on those key objectives as well as a number of other things that we'll learn here today. So who is this for? Well, if you're here, it's for you, right? But a lot of the folks that we work with, you know, we are very much a geospatial and remote sensing company. So really everything we do has some matter of geospatial connected to it. And so with that, we often work with GIS analysts and leaders within GIS organizations because you're tasked with taking this data, integrating this data, running further analysis, and providing this data to end users within your organization, right, to really make the most of it. And very often that data is ending up within operations, it's ending up within integrity, within risk, for further analysis, right, for the day-to-day work that, whether you're a risk engineer, whether you're focused on the pipeline integrity component, or if you are a geotechnical engineer, whether you're internal to your organization or third party that is working with these pipeline operators hand in hand in parallel with Teren. A lot of this information can help bring that into your particular workflow to, again, speed up or make more efficient some of the analysis and tasks that you may be doing. And then as well within operations, within the executive role, a lot of this information rolls up into an ESG framework. A lot of this information, again, is really geared towards minimizing risk on your assets, whether that be keeping product flowing through the pipe, whether that be to ensure the safety of people in the environment around those assets. So we'll touch on all of these facets hopefully throughout. And so with that, I want to hand this over to Brian. Again, we really appreciate having you here, Brian, to talk a little bit about where the rubber meets the road and where some of this data then really aligns with real world and some of the incidents that we've seen over the years.
Thank you, Jake, and thank you, Stacy, for the intro. Hearing all that at once is a little it's a little much, but yeah, I've been at this just over 20 years, 24 years to be exact. So it's great to be here, and I'm excited to present the solutions offered and what we can bring to the industry and pipeline operators specifically, especially with the current conditions in which pipeline systems operate and the regulatory compliance requirements that PHMSA has put forth in recent times. So with that, I kind of want to level set here and talk about some recent incidents that we've had in the industry. These pictures here on this slide depict 3 specific cases, and obviously these don't cover everything that we're seeing these days, but I think they speak really well to the Teren model and what solutions we can glean from it. So number 1 here, we have an active accelerating landslide that was identified previously and actually just got worse over time. And we believe that the solutions that are presented today will help prevent these sorts of situations because of the active, ongoing management and monitoring of the areas like that. Number 2, we have a weather event that was an anomaly, and we'll talk a bit about that later on, about how those weather events coupled with the geohazard likelihood that we see in the soils and the subsidence that is specifically mentioned in the PHMSA guidance documents. This specific crater that you see at the bottom was a CO2 line and an incident that many people on the call probably are familiar with. Number 3, of course, all over the place these days, we have flooding events and areas with river scour that may not have previously been identified in the methodologies that we've used in the industry to look at where these are threats. So this is something else that's offered with the solution that we're excited to bring. So as I mentioned, PHMSA in 2019 and 2022 brought these guidance documents to the industry and said, hey, we know that with 192 and 195 integrity management, you guys have been handling geohazards, but we can do better as an industry. And that's what this is all based on. As well, I want to mention that as a metallurgist and an overall material integrity engineer, sorry, I got to put on that hat for a second. As an integrity engineer, we have to look at this in a full-scale integrity management plan way. And with that, we'll bring in some material and seam issues to these sorts of situations. And that's important to pay attention to as well. So if you could move on. So just going back a little bit, I mentioned this previously, 20 years ago when we had the first subpart O and 195.452 rulings come out, the risk indexing and risk assessment areas are techniques that we had in the industry were largely binary, and they were very simplistic, very reactive to situations that we had on the right-of-way, not really predictive in nature. And that's what we're going to here with this Teren solution and where we're going in industry. So what we're doing is we're using leading indicators with this data and analyzing it for those areas that we actually see a higher probability in the future of having geohazard concerns. And just finally, I want to level set on a geohazard program just a layout, a framework that we use. One that we've seen that various clients have used is this identify and assess, plan, mitigate, and monitor. Right here today, we're going to talk about the identification and assessment of these geohazards. Not going to focus too much on planning and mitigating. That's more of your in the ditch, in the field mitigation measures that you have on the right of way. But we are going to go into that monitoring piece, especially with the forward-looking risk assessment and predictive modeling that the Teren solution on the weather side offers. So with that, I will pass it off back to Jake.
Thank you, Brian. And yeah, we'll be hearing from Brian again here later to kind of tie things further together, right? When we talk about where we start with some of this data and what we can do to help facilitate some of that initial assessment, right? And what we do in our approach, and you see here in this graphic, if you see to the right, which really aligns with what Brian was talking about, this methodology or this approach to begin with this assessment, right? And very often, some of the conversations I've had with various operators, it can vary. There may be very mature geohazard programs in place where we may come in at a certain step, and there may be programs that are just getting started. And I've had folks say, well, we don't even know where to start, right? In our follow-up webinar, we'll be talking a little bit more about what Teren does to utilize LiDAR data to go identify these discrete geohazards. But here today, we're talking more at a broad scale to really start to understand and assess those threats across an entire asset footprint. And so what Teren does is we leverage a number of different data sources as well as a lot of expertise. I'm very lucky to work with some brilliant people here at Teren. A lot of this is going to start with sensor data. So I mentioned LiDAR. We're not really going to touch on LiDAR so much here today, but we're still leveraging remotely sensed data, be it imagery, national elevation data sets, things of that nature that are primary inputs that we utilize in conjunction with environmental data. And so we're going to touch on that as well. You'll hear us talk about soils a lot, precipitation. There's a lot of these other data sources when coupled with sensor data that can then begin to provide a much clearer, higher fidelity picture of potential threats and risks along a right-of-way, along a roadway, near whatever asset you might be managing. Bringing all that together at the asset and the infrastructure level, then we can start to identify where these things intersect and where those risks might be most prevalent. And so again, this idea of an environmental twin, where we can leverage all of this data to help make a digital representation that's accessible, that's usable, and actionable in this process of assessing threat, starting to prioritize next steps, and eventually monitor and report on those. So, a quick look here at some of these different threat layers available here within the Teren Essentials platform. We're not going to cover all of these today just for sake of time, but we will hit on a few of them. But as you can see here and in the graphics, you see at the nationwide level, these different threat layers. Whether we're looking at subsidence, karst geography, things of that nature, looking at sinkhole problems, landslides, obviously one of the big hot topics within the industry here today, as well as some other layers here that really aren't commercially available or readily available for most, looking at different depth of cover issues, be it from dirt roads, be it from agricultural practices, looking at seismic risk, river scour, which Brian mentioned before, another hot topic, looking at where these threat layers coincide with potential flooding and erosion, things of that nature, as well as wildfire, another very hot topic, even within the pipeline industry, starting to have those conversations about wildfire risk. But within a number of industries, that's something Teren's been doing quite a bit. And then you'll hear us talk again and circling back to one of those key learning points, right, around weather, around climate-informed data. All of this information, a lot of it is somewhat static. If we're looking at a hill slope, the percent slope of a hill slope and what that might do to affect the potential for a landslide. a lot of that data being static, we're looking to find ways to make this more dynamic, more near real time, and more informed, and weather can help inform that quite a bit. Obviously, precipitation, hydrology plays a large role in these things such as landslides. So we'll dive into a few different aspects here of this. And if we want to move to the next slide. So many of you may be saying, all right, well, we're already doing a desktop study. We're using data like this to perform various desktop studies to help inform our geohazard program, prioritize, and so on. And a lot of that data is out there, right? Some of this data that we'll talk about isn't really readily available. But we have noticed in our conversations, in our R&D, and as we brought this to market, there were some lacking components in a typical desktop study. One of those being really the ecosystem science behind that, right? A lot of the publicly available data or commercially available data isn't really infused with some of this ecosystem science, right? And we'll talk about some of those aspects, and we touched on them a little bit already. As I mentioned, the climate-informed component, again, a lot of these available data sources may lack that near real-time information, such as temperature and precipitation. And as I mentioned early on, statistical validation, right? You need to be able to be in a defensible position with this data, whether it be from a risk modeling perspective or within your integrity program. And so the ability to statistically validate this, not only to give you confidence in your decisions, but confidence in your defense of this data. Most of these public or even some of the proprietary models have not been validated or may just not be sufficiently performant in their validation. Finally, just accessibility, right? Again, a lot of the data or types of data that we're talking about, they are available, right? But at this nationwide scale, that requires a lot of computational power. And that can really inhibit the actual usability of this data. That's something Teren definitely prides itself on, is our ability to work with these very large data sets, leveraging high performance computing, machine learning, things of that nature, to provide this data in a very usable format. And so, following on to that, what has Teren done really to address some of these shortcomings and bring these layers to market? Certainly the ecosystem science, again, being able to work with GIS-focused soil scientists and geomorphologists really is a blessing here at Teren. To be able to start to integrate these other variables into the data, such as soil conditions, hydrology, we'll touch on our hydrology models a little bit here, and other data sources here that really further inform that data. Of course, the climate piece here, we'll look here in a moment at a demonstration, how we can start to infuse things such as precipitation to help inform these models as well. The statistical validation, we'll touch on some of this really throughout the presentation, but for example, our validation has shown that 93% of these landslides, right, are validated and fall within where we would expect within the probability and the risk metrics that we have within this data source. And then we'll see here in the demo the ability to actually access this data. We'll show a couple of different ways in which this data is delivered, be it within our viewer that I'll show here in just a moment, as well as the native GIS data that you can bring internal for further internal analysis and or working with your third-party geotechnical engineers, things of that nature. So with that, before I jump into the demo here, I think we were going to do a quick poll, get a little engagement from you here, and then after that, I will jump into the demo.
That's great. Thank you, Jake. Yeah, while you're getting the demo pulled up, please everyone take a minute. Has your organization conducted an external force threat assessment like we're talking about today? Please let us know if this is something that you've done, and we'll look at the results of the poll here in just a minute. All right, it looks like we're getting some of the participants. All right, I'm going to end the poll here. Thank you to everyone who participated. And let's share these results. Yeah, so a lot of folks on the call have conducted an external force threat assessment. So I'd be really curious to know if the differentiation that Teren's providing is something that you see that, and if it stacks up against what you've done. And those of you who haven't or are not sure yet, we're hoping that you take away some key points of what you should be looking for and doing when you do that external force threat assessment. So we're going to close this, and looks like you have the demo up, Jake, and we'll let you get going.
All right, thanks, Stacy. Well, I will probably zoom through this pretty quick. You know, certainly we look to engage with you following up on this and dive into some more detail. What you're seeing here is Teren's 3D viewer, web-based GIS viewer. This is one of our standard deliverables with really all of our products. Very fit for purpose, performant way to get to this data quickly. As you'll see and hear from Austin here shortly, this information, really everything you see here often is also delivered in a standard GIS formats, whether that's delivered to you via file share or hard drive, as well as the ability to stream this data in with, for example, ESRI compliant streaming services. But what we're seeing here right now, and for my pipeline folks, apologies on the dummy data here. We didn't take into consideration routing or field bends, but wanted to just create a demo data set for the purposes here to share this information. So you see this, this demo pipeline data set here, right? And for example, this is something we engage with a pipeline operator, providing your center line, and then we can begin to go through this analysis to generate these different threat and susceptibility layers as they relate to your particular asset. So if you see on the left-hand side there, the different layers, again, we've only brought in 3 of these different threat layers here versus the 8 or 9 that we mentioned earlier. But if we start kind of at that nationwide level, right? And so we'll start here with this depth of cover due to agriculture threat layer. And so certainly if we're talking agriculture here in the kind of mid-con region, central US, where a lot of agriculture is going on, you can see here at this nationwide level, we start to get this picture of where some of these higher threats may be related to depth of cover, right? And specifically in this case, related to the potential soil loss or depth of cover issues that might come from agricultural practices, from soil loss, be it from the practices themselves, be it from wind scour, things of that nature, right? And so if we take this information and start to intersect and analyze that with your centerline information, we start to get a picture, as I zoom in here. And what we're looking at here is that same information then clipped to a buffered centerline, right? And so now we can start to see, and if I switch to my legend here, you can see broken into 10% breaks, right? The percentile category here of risk for this particular threat. Now, if I break that down even further, we can see now that this is summarized to the center line. So this would be an example of one of the deliverables would be dynamically segmented, a sliding mile, linear referenced, if that's a requirement for you, be it from a risk model input perspective or other use cases within your organization. But now we have a measure of threat here and risk along that pipeline related to this particular threat layer. So some of these layers here, in particular this depth of cover due to agriculture, to our knowledge, that's not something really commercially available. Right? So some of these layers, for example, landslide, which we'll touch on here in a moment, a lot of folks are using the USGS data layer for that. Right? Some of these simply either don't exist or, again, don't have the level of fidelity and detail and informed with data science, soil science, et cetera, to really give you this clearer picture. So for example, this depth of cover data set here, For agriculture is going to include wind patterns. It's going to include precipitation, temperature, other variables. For a road-related depth of cover, we'll be looking at those particular road types, and again, those same other climate and earth science-related variables as well. So we begin to get this clearer picture. This data then can be, again, infused into a risk model. It can be used for prioritization of next steps, which Austin will talk on. And while we're in the viewer here, we can certainly look at some of these other data threat layers as well. So we looked at depth of cover. We can again look at river scour. And as we turn that on, we can start to see that we'll see things flagged out right along waterways, right? But going beyond where is there a stream or river crossing, right? We can start to look at hydrologic power, stream power that we built out over the entire lower 48 here within the US. This is something actually that's pretty compelling and difficult to do, is to piece together hydrology in a manner that accounts for all of these disparate watersheds at this grand scale. So that's the type of information that we're infusing here. If I go over to my river scour layer, and we can zoom in here, and again, as we would expect, we're seeing things highlighted where they are adjacent to riverways and things of that nature, but also taking into consideration beyond just that basic, hey, there's a stream crossing here, looking at hydrologic power, looking at potential flood events, things of that nature, right? And again, this is broken down here at the centerline level, where we can begin to go and look at this along a sliding mile to find where those particular risks are, which again are going to help us perform, follow-up inspections, things of that nature, right? Certainly, last but not least, we'll talk about landslide. So I'll zoom out here a bit again, and as one would expect, if I go to my landslide layer, we're going to see a lot of the highest risk within Appalachia. It's where a lot of our customers are leveraging this data, as well as out to the west. But really, even throughout the US, there are areas that, because we're able to break this down at a 10-meter resolution, which should be noted compared to USGS being at 100-meter resolution. So a lot higher fidelity to be able to start to pinpoint these areas of risk. So why don't we go on over here to Appalachia, and let's turn on our pipeline layers here. We'll turn off that main base layer. And as one would expect, we're seeing a lot of red here within Appalachia. If I zoom in a bit here, again, same concept as we saw before, but we can start to have more information at our fingertips here where there is potential risk, right? And again, down to the summarized to the centerline level, right? So again, looking at this example with a landslide, potential landslide risk layer here, 10-meter resolution versus 100-meter at the USGS, forward-looking model as well. So USGS is a historical database of landslides, largely focused on percent slope, things of that nature, and that historical data. Whereas Teren's data here is a bit more dynamic and much more forward-looking. As I mentioned, we do a lot of work leveraging LiDAR data to actually identify, delineate these specific geohazards, landslides along a right-of-way. All of that information continues to be fed back into the system to inform our model, right? So through machine learning, we're continuing to inform that data with not only the historical landslide information that we can leverage from the USGS, but all of the forward-looking information we have collected, continue to collect, that feed into this model. Of course, that coupled with robust soils information, being able to bring that soils information, be it Surgo, StatsGo, et cetera, together at a nationwide level, being able to leverage hydrology, again, our hydrologic modeling, very impressive and robust in what we're able to do to implement that data and integrate that data here. And then finally, the climate piece is something we've talked about as well. So we know that along this pipeline, we can see here in the Appalachian region, there's a lot of red, right? In Appalachia, you can't throw a rock without hitting a landslide, most likely. So no surprise there, right? But is all risk equal in this case? Well, we can start to further prioritize when we bring weather in. And so what I've done here is I've turned on this precipitation deviation from normal layer. And so what we're doing is we're scraping NOAA data on a daily basis, but in this case, summarizing that at a monthly level and running that comparison against the 30-year average of normal precipitation. So in that case, and if I switch to the legend here, we can see percentile below or above normal. And so now we can start to integrate that information to say, well, yeah, we may have some higher risk here, but it's been pretty normal precipitation, right? Or in fact, we may find areas that have been below normal precipitation. So perhaps that reduces some of that risk. Whereas, as you can see here, these purples here representing some of the above normal, we may pinpoint that, well, this may have been, a medium risk, but there's a high degree of precipitation over the last month that perhaps that's something we need to be concerned with. Certainly here, where we do have a lot of red combined with above normal precipitation, we now can see and learn even more here from this data to help inform us, to help inform you on your next steps from there. So for the sake of time, I will probably wrap up that demo again, happy after the fact to go into further details. And with that, we'll cover here a few more things. And let's see here. Okay. So again, we've mentioned kind of throughout here the statistical validation, which really does matter. And in this particular case, as far as landslides are concerned, 93% of those 8,000 recent landslides that Teren has actually acquired and delineated, they align within that high landslide risk prediction model. So starting to validate this data again for a number of different purposes. Now, we've talked a lot about pipeline, and we can go to the next slide there. Thank you. Did want to bring up another example here, and this is related to wildfire modeling. A lot of work that Teren does around wildfire modeling, both predictive as well as looking at post-wildfire debris flow modeling, very similar mechanistic components as landslides, as I'm sure you can imagine. I won't read through all of this. You're happy to screenshot it or ask questions as we go, but in summary, with Teren's model versus, say, the USDA historical wildfire model, you can see there, even at the bottom right, it's a much more normalized distribution. We're seeing where those rankings that we are predicting, we have a lot more correlation to falling within existing fire perimeters. So again, further statistical validation there. Looking at a higher resolution model, again, the fidelity of this data often matters. And all of this is really boiling down to we're seeing upwards of 30x the validation, right? The statistical validity of these particular models compared to some of those historic models. And so we continue to do a lot of work to validate these, to work with our customers to be able to provide that information so that you, again, have that both internally as well as if needed to share with auditors, things of that nature. Okay, so with that, I think I'm going to hand this back over here to Brian. And again, he's going to talk a little bit more about once we've delivered this data and this information, where can we go from there to again start couple up these different data points for more informed decisions. Brian?
Yeah, thanks, Jake. If we could just go back one slide, I'll talk to that really quickly. Yeah, thank you. And by the way, Jake, I just noticed something. We hadn't talked about this previously, that 30% more accurate is the reason why we all started talking, Pipeline Logic and Teren, last year actually, because we were taking USGS data and putting it into our risk models, and we've been doing that for a number of years. But this just takes that to the next level. So I just want to throw that out there for the audience and the Teren team, because I don't think we'd specifically talked about that. So, you know, what we're getting here is just a much higher fidelity level of likelihood of failure if we incorporate this into our risk models. So what I want to show here, this is just exactly what Jake was just going over here. So on the right here, we have a high threat of landslide and a high precipitation area. On the left, medium high threat of landslide and a high precipitation area, and then down below, low threat of any geohazard. So if we move on, I'm going to go through this real quick because I know we're kind of running out of time here a little bit. So want to emphasize here that in our work with Teren, we've received this data in multiple formats. They're very flexible. Austin's team can deliver that in whatever format is needed for the team at the pipeline companies and other consultants as well. Apologize for the noise, by the way. We had an internet problem, so I'm working from a cafe. So a couple items here that I wanted to go over from a risk assessment standpoint of putting this into a risk model in an ad hoc way. Number one, I mentioned this before. So if we take the Teren data, the geohazard modeling data, and we overlay that, number one, on seam and girth welds, the seam type and girth welds that we have in our system. One thing that we'll see is, and PHMSA has been talking about this for some time. There's been a lot of literature published in the industry lately. There are two areas of specific concern. Modern high-strength steels often have ductility issues around the seam, leading to rupture. We've seen a number of those incidents recently. And also our vintage pipe, welds with low toughness or susceptibility issues, like low frequency ERW. These are some of your vintage steels from the 40s and 50s that those of us as integrity engineers, we've been attuned to for a number of years, but this is an emerging sort of threat that we've seen just more recently. In addition, another example that I want to go through, high strain areas determined by inline inspection. This is kind of an emerging offering that we've seen in industry. A number of people are talking about this at various conferences. Number one, we have technology in-house here at Pipeline Logic to work with two previously gathered ILI runs and use the IMU data and a fast Fourier transform technology to look and see where there are high strain areas that may correlate to these areas that Jake went over. And in those cases, we would have areas that we would want to look further into. Number two, previous single run, I actually missed MFL and caliper data. So again, IMU data, we can go back and look at that for high strain areas. There are a number of people doing this, as well as our most pipeline vendors, or sorry, most pigging vendors at this point, as a part of writing a new contract for pigging, offer strain analysis as a line item on that, and that's one of the things that we can bring into the program as well. One of the things that I think that sets the Teren solution apart at this point is that road and agriculture erosion threat layer. We have not seen that in industry to date, except from Teren. And I know specifically, I was on a utility pipeline in the west of the U.S. a number of years ago, and there was an area where a 24-inch line was just sitting at the top of the. It was actually on an embankment, and people were driving over it with farm equipment. So those sorts of threats and those sorts of real-world situations are addressed with these data sets. So just want to level set there. So if we could move on. So going back to Jake's example and what I went over with seam and the seam threat, when we put these into the specific risk model that we may have in-house, there are various scenarios that could be observed due to the combination of factors that drive that overall risk. One of the compelling cases is when the seam or the material issues could be a factor, of course. And this is where, when traceable, verifiable, and complete data for those areas becomes very important in a practical sense. Because in the case of geohazards, some of these areas could have been mitigated in the past. As I mentioned originally, we were talking about old risk models. A lot of those were very reactive. So we knew about these areas. We may have, or our previous owner may have gone in and actually mitigated it, but unless we have TVC records, we don't know about that. So this is where we see this come into the entire integrity management program. It's a holistic sort of attitude that we have to have about this. And so the Teren solution is one piece that brings the whole together. So whatever type of risk model is used, accurate likelihood is built from the reliable sources of that data. So here on this specific example here, I just wanted to mention that one of those scenarios that we could see is that area on the left that was previously thought to be higher risk. It may not, I'm sorry, the one on the right that might be higher risk may not be because of that seam issue. So bringing that into the situation would let us know that we actually need to go after and mitigate the situation that you see there on the left. So with that, I'm going to turn it over to Austin, and he can go over a little deeper into the weather.
Awesome. Well, thanks, Brian, for the introduction here. Stacy, I know we are kind of short on time, so I'll try to go through this here pretty quick. So, kind of where I'm looking at this is, what I've seen over the industry is you have these very, very large nationwide assets, right? And a lot of times the decisions for kind of the monitoring and kind of some of the mitigation efforts I think there could be more to be optimized, right? And so, kind of when you're looking at these overall large size, the question that I always get is help me understand where I can get the most bang for my buck in terms of this, right? When it comes down to really mitigation and kind of monitoring, at the end of the day, a lot of this does wrap up to a budget, right? And so, this kind of new approach to kind of identify individual areas for prioritization is trying to really address that issue where everything kind of wraps up to a budget, or you may have budget on one year versus the next. So really trying to get that kind of the most bang for your buck. So, the way that we're kind of looking at this is really kind of the difference between objectivity and subjectivity, right? And so the way we're kind of going at this is we're trying to inform your mitigation plan or monitoring plan really based on facts to have it, as informed as possible, and not just a, check box. Hey, we have a LiDAR survey on this full line, and then we're going to do it the next year, right? So it's really trying to dive into those exact information to really help make that best informed decision. So in this example here, we have a very interesting, center line here. It's quite linear. And so, I use this as an example because, there's been a numerous amount of occasions where I've seen a nationwide asset, and the question comes, well, I want to have a LiDAR survey on it. I want to have aerial patrol. I want to have an ILI run. Where do I go? And so a lot of times sometimes it just starts with, I want to see a quote for the nationwide asset. And, that gets a little scary when we start presenting numbers. And so we really try to kind of take that risk and try to kind of slim that down so you can start really prioritizing and kind of, adjusting where your methodology may go from year to year. So Stacy, if you want to go to the next slide. So kind of what I did here is so I took our landslide layer. We could do this for really any layer. It doesn't have to be pipeline. Any type of linear asset would work, or even just polygons. Right at the end of the day, what we're doing here is really running intersects off of our national base layer. So I know we've been very focused on pipeline, but I know I saw some questions about other industries. So I just want to kind of point that out, that this is not tied to just pipeline, really any linear or polygon shape. And so kind of what I did here is I took this data, and this data is all linear referenced. And so I intersected it with our landslide risk. And so, I've chose the top 80 percentile for this specific example. And, what we've seen with this top 80 percentile is a lot of times when we're presenting this data, our customers and clients are asking, why 80%, or how should I interpret this? And so we went back to, to a lot of our scientists, and we made a bunch of statistically robust models to try to identify where that kind of threshold is. And so how we landed at that top 80% is we looked at the nationwide lower 48 USGS landslide. I think it's just roughly 24,000. And so we intersected all of that within our landslide risk models. And really what we found was about 95% of those slips fell within 80% or higher of those zones. So as of now, with the data that we have at our hands, we find that we feel pretty strongly that this top 80% is a good place to start. Now, depending on your budget, depending on kind of the timing of the year, you can then take that 80% and further narrow it down to wherever you may go, right? 80% is kind of where we see, but you can always slim that down even more. So kind of what we see here is we started at that 8,600 mile mark, and so now looking at that 90 percentile, we removed all the way down to almost 1,000 miles. And if you even furthermore, Stacey, you want to go to the next slide? Even just looking at the 95th percentile, we were able to even slim that even more, almost by half. So now we're at 532 miles. So when you're looking at this scope, I think it makes it a lot more palatable for you in terms of identifying what that budget may be, identifying certain regions of concentration. And also it really helps the contractors help kind of coach those operators into what is that best solution, right? Because now we're not looking at 8,000 linear miles. Now we're looking at 532 miles or 1,000 miles. And so this is kind of a different approach that we're seeing, right? A lot of times it's a lot of RFP based. And so we're trying to take this into more isolation and more informed decisions. So Stacey, if you want to go to the next slide here. So I kind of touched a little bit on how you can kind of step down these linear miles. So in this table here, you can kind of see how that may transpire. But I do want to kind of concentrate on some of a way of interpreting this, right? So when we're looking at that, it was pretty clear that there was at least 3 or 4 really defined regions of concentration of those 80 percentiles. So at the kind of that bottom left over here, you can really see there's a high concentration in Appalachia, New Mexico, the Ozarks. So you can look at that. You can look at those 3 sections and you can separate those into different timeframes of the year, right? In New Mexico, you don't really have to worry about leaf on, so you can prioritize that in the summer, versus where Appalachia and the Ozarks, you can start hitting that into the winter, right? So it's able to kind of dissect that from a project management standpoint and really add a lot of efficiency to that. So, in terms of looking at how these methodologies can help you, I kind of touched on this, is yearly mitigation planning, right? So when you are able to kind of isolate that, you can kind of pick and choose what systems may be at a better benefit for this year's budget or next year's budget. The next thing that I see a lot of times is when they're going into these new years or budgeting cycles, it's very hard to quantify how much budget they should be asking for, right? And so we really try to kind of get in there and get a high level assessment to really inform what that budget forecasting may look like, right? So let's say you have a system, you're going to have, you're going to need some monitoring on it. You want a LiDAR flight, aerial patrols, IoT, even down into ILI runs. So you can use a lot of these analytics for forecasting to see what you may be able to expect in terms of some of your mitigation efforts. The third thing is identifying the most efficient and monitoring mitigation methods. So I want to kind of point you to the bottom right of this slide is, so you'll see that there's outliers, right? So when Jake was kind of showing that nationwide scale, you can see kind of the Midwest, there's some sparse little areas, right? Whether it's soil type, geology, different little type isolated zones, right? So when you start looking at these isolated zones, that may drive you into a different methodology for monitoring mitigation, right? Whether we're talking ILI runs, aerial patrol, even just boots on the ground, right? You may not look at a 10-mile segment and say, hey, I want to send a plane out there to go fly, right? So you can really kind of dive into it and narrowing down what that best use of technology is. So the next one here is really risk by asset. So, since this is just a dummy center line, I didn't have it broken out into individual locations. But the nice thing is if you do have an asset, and I assume it is broken down even further by asset or line or type, we can actually narrow down and linear reference this data to individual lines. So you can get a even broken out report that can really go into your forecasting and mitigation planning. The next one, I think I touched on that, is really, aerial collection planning. You can get a lot of benefits from that standpoint. But ultimately, what this is really wrapping up for is a lot of the questions that in experience I've seen in the industry is efficiency and really being informed on that use of the budget. So that's really what we're trying to dive into is really stick numbers, science, and facts to the decisions you guys are making in terms of your mitigation efforts. So with that, I think I'm passing this to Jake. So thanks, guys.
Thanks, Austin. Well, I know we're about out of time, and hopefully we can have a couple minutes here to address a couple questions. I'm not going to read through all of this. Hopefully we did touch on these points. If there's anything that we didn't touch on, please do follow up with us after the fact. There's a lot here to cover, and there's a lot to cover about what we can do to help you with this data. But we did hopefully touch on these. And, first and foremost, thank you for everyone here who joined us. Next slide. We also want to, touch on this last slide here. Thank you, Stacy. Where again, we really did look at that assessment piece at first. We hope you can join us for our next webinar in this series, where we'll start to talk more about that prioritization and monitoring. Austin touched on it. Very often what we see coming out of a essentials program is helping an operator figure out where to, for example, acquire LiDAR and then perform that more high fidelity assessment to find those actual discrete geohazards, right? So we'll cover that in our next portion of this series, where we actually go through, identify those, go through a ranking system, and provide that data as well for further prioritization, where then you may begin to do those mitigative efforts. How do we monitor this over time? Really big component here that we didn't touch on here, but when it comes into play with LiDAR acquisition, is that change over time. Can we monitor those particular hazards? Are they moving? Are they changing? And then how do we report that eventually is what we'll get to next. With that, I know we've only got 1 minute officially left. I do also want to mention, as a thank you for those of you who attended, we are offering a bit of a promotion to run a portion of your system through this Essentials platform and review the output from that with you and go from there. So please do follow up with us, and I'm sure you'll be hearing from us after the fact as well. And with that, I'll hand it back over to Stacy.
Awesome. Thank you, guys. Really informative information today. We do have a few questions that have come in, and I'm going to prioritize them by, I think, probably the one that I'm most excited to answer. And actually, I'm going to ask Brian to please answer is can I use this data to meet compliance requirements, regulatory compliance requirements?
Yeah, thanks, Stacy. Yes, absolutely, and that's why we were so excited to find out about what Teren was doing, because this, in our minds, did answer that question it heeded the call that PHMSA brought up. It's not a turnkey solution necessarily, because there is a mitigation piece in the field, but absolutely for prioritization. The assessment of geohazard risk on the pipeline system, absolutely, this is a fantastic solution for that, and it does meet regulatory compliance concerns on the onset.
Perfect. The other questions we have in here are great questions. Using this data to validate IMU data, it's such a great topic. I think I will ask, I can hand it over to Jake, but in the interest of time, I think we'll really cover that in our next session in part 2. But if you'd like to comment on that, Jake, that'd be great.
Yeah, real quick anecdote on that. Within our analytics, our more premium system where we leverage LiDAR data, we do run a depth of cover analytic if we have IMU data from the operator. And typically what we're doing there is running a delta to find where there may be areas of concern. But we've also found when we run that analytic that the results show that your pipeline is 60 feet above ground. And here in the lower 48, that's not the case, right? So it has helped to flag where some of the IMU data was bad, right? So it can be used kind of in both manners.
And just one note to that is, and when we have seen these, kind of these offsets, right? We've really started to dive into understanding the AGM data and taking that AGM data and kind of calibrating that with a LiDAR to kind of offer some of those fixes. So, you know, we have had a good bit of experience right now trying to fix those 60-foot offsets using our data. You know, so it's certainly a very hot topic right now.
Absolutely, absolutely, and we'll definitely talk more about that in the next webinar. I'm gonna ask this last question as I leave you with your information to contact Brian, Austin, or Jake. You know, the last question we received that we want to cover before we sign off a couple minutes late here is, what other industries does Teren work with? This was obviously a very pipeline-oriented webinar, but you can imagine that this external force threat monitoring and assessment applies to others. So Jake, would you like to take this question to close us out?
Certainly, yeah, and a great question. And yeah, I know we were very pipeline focused. We do work in a number of different industries. For example, DOTs, very similar use case there, long linear asset, be it a roadway instead of a pipeline, but subject to those same types of risk. We work a lot within the renewable space. There's a lot of ongoing solar development and other things of that nature where these types of technologies can be very helpful everywhere from pre-construction, looking at potential analytics around shading from trees, looking at erosion, other aspects there. We do a fair amount of work just within kind of the civil survey area as well, where sometimes LiDAR-based contours and terrain data can be effective, efficient, quick, and even more cost-effective than traditional boots on the ground methodology. We do work within the federal government as well around wildfire predictive modeling and post-wildfire debris flow modeling. Huge project through the USDA and the NRCS for the Hermit's Peak Fire in New Mexico, where we've done a bunch of work there. Utility space, again, in particular utilities leveraging pipelines within electric utility, right-of-ways, vegetative management, things of that nature. There's so much information and measurement data we can pull from these remotely sensed data sources, as well as compiling that with these other external sources of soil science and things of that nature, plus just leveraging industry expertise to really make the most of this data and turn that information into something usable. So there's other industries that I haven't even mentioned helping within the insurance space. Again, a lot of that wildfire focused things of that nature. And I probably forgot one or two, but that covers some of the big ones.
Yeah, I think you got most of them. So thank you for taking that. Thank you all again for joining us today. We really appreciate you spending a couple extra minutes going over the top of the hour. Brian, Jake, and Austin, we're really grateful for you lending your expertise to us. You will receive a follow-up email from Teren thanking you for attending and inviting you to participate in a survey. You are more than welcome to reply to that email to take advantage of the offer that Jake provided, where you can get a free assessment of your system, and we'll review the data with you and help you start to identify areas of those greatest external force threats. So thank you all again for joining us. Thank you to our speakers today, and keep an eye on your email for more from Teren.
Thanks, everybody.
Thank you.